and I'll just say a few words and we'll get rolling. So hello everybody, welcome to this Reactive Systems meetup. It's also a joint meetup with SF Scala, SF Spark, and a few other meetups, and it's a meetup open worldwide as we do now on Zoom. My name is Alexey Krabrov. I am the founder and organizer of this meetup since 2015. And recently, I became a general manager of the Reactive Foundation, which is a new Linux Foundation organization specifically set up to support cloud native applications with reactive streams, and also building reactive systems as resilient, message driven, and elastic, right? So there are two meanings which we care about, and I'm very excited to introduce our first talk on R2DBC. It's a reactive driver for relational databases. It was originated at Pivotal now, which is a part of VMware, and it's an open source project which is on the verge of being inducted in the Reactive Foundation. And so we're very excited to have a talk on this from Rob Hedgepeth, who is the developer advocate at MariaDB. I found his excellent blog post, and it's a true kind of ground up movement. The R2DBC is a very vibrant project already. It has a website, it has a Twitter handle, it has a GitHub, it has a lot of stuff, and so I'm really excited that Rob basically found it and played with it. And obviously MariaDB is a very well-known and liked company in the community. So so I think it's a really great talk to have. So Rob, without further ado, I'll let you run the show. If you guys have questions, the way we do it, I type the questions in the chat, and Rob can review them as he goes. He can choose to answer them right away, or he can wait until the end. And obviously, in the end, we can have a discussion with everybody speaking on Zoom using, video and voice. If Rob, you feel like you want to take question over voice at any time, just ask folks to say whatever they want to. Right, it's really up to you how you want to run the Q&A. And without further ado, welcome, Rob.
Yeah, thanks, Alexey, and yeah, thanks very much for reaching out and letting me join up on this meetup. I'm pretty excited to talk about it. As you mentioned, I'd written a blog post and I had done a session at MariaDB OpenWorks, which was digital this year, on this. And at the time, R2DBC, the implementation from MariaDB, R2DBC, was in Alpha 2. It recently just switched to Beta 1. So we are kind of moving it along the pipeline, but as you mentioned, MariaDB, popular, but not very large from a corporation standpoint. So each of our connector developers actually has two connectors that they work on, right? So the person that works on R2DBC also works on the Node.js connector. And so we've got this kind of massive workload, among these developers. So moving it just along, as fast as possible. But one of the things that really helps is joining meetups like this and, getting the interest from you and, others basically to say, hey, this is something that's really important to us. We want to see some traction into it because, like any company, unless there's some kind of interest coming into it, this is, something that, won't gain traction unless we actually can provide that feedback. So this is really helpful. Anytime you want me to come in and talk, and to be honest, I would just like to join the meetup to learn more about it. As I mentioned before, and something that I'll caveat, I am actually pretty new, and that's bright, so hopefully your screen's not extremely large or you're in a dark room, but I am currently working in developer relations at MariaDB. I have been an application developer for over a decade at this point, starting in web. I spent a long time in mobile. I worked at a company called Xamarin, which is a cross-platform solution, which eventually was acquired by Microsoft. Spent a lot of time working in C#, and so I'm actually newer to the Java side and JVM in general. And I got to say, I'm a huge fan of a lot of the things that I've seen so far. And I'm really excited actually to be working with R2DBC specifically. And we were talking before, Lexi, that I actually have been in the process of writing a book on R2DBC, and it is an extreme learning process, because writing a blog post, right, is one thing, and writing blog posts is something different than writing a book. It is I have had to be very scheduled and very organized in order to be able to do it. But it's been a really good process, and I've learned a lot about mostly what I didn't know, and especially things that I didn't know. So that's been pretty exciting to go through that. If you want to get a hold of me anytime after this, you can hit me up on email, obviously, Twitter. After seeing me write some live code, which is the demonstration portion of this, you're welcome to go and judge me on my repo out on GitHub as well. It may be warranted after you see some of this code, right? I do say I am newer to Java, so don't judge me too harshly, but do judge me, because I think it's probably warranted. So here's the agenda really that I'm going to go through. Now, like I had mentioned, and some of these are tagged, sorry for the kind of MariaDB templated presentation. Usually whenever I do meetups, I like to keep the marketing aspect out of it, just because I'm really more focused on the development aspect of it. But I did give this a similar presentation. I've modified it for here to a group at the MariaDB OpenWorks conference. And like we had been talking about at the beginning of this, is that the idea of reactive programming and really using reactive systems as a whole, and this whole concept of reactive development is kind of foreign to people. So I like to start it off not knowing anything about the audience with an introduction, and hopefully it's not too basic for you all, an introduction to reactive programming. And mostly it functions as a reminder for myself and really kind of sets the stage as I work into R2DBC, what it is, what it really means, as far as development in the future of reactive development within relational databases, and how we can actually use it. And I use all that really as the foundation, because I want to jump a decent amount of time into a demo. Now, the demo itself isn't anything complex, but what I like to do is start with nothing at all, right? I'm going to use Spring Initializer, and I'm going to create a new Maven project. And from there, I'm going to create just a simple Spring Boot application that I'm going to integrate into MariaDB's R2DBC connector directly into a MariaDB database. So we can see in a matter of about 10-15 minutes of just writing code that you can actually get started using it with Spring data repositories and the R2DBC integrations that they have available now. So I will stop blabbing on this agenda and move directly into it. So reactive programming, what is it? Well, when I first read the message that's out there as the first, kind of introduction into reactive programming, I mean, it reads that, a declarative programming paradigm concerned with data streams and the propagation of change. Now, that is a lot of computer science shoved into a single sentence. And so, having more of a background in more imperative approaches, not really familiar as much with declarative programming as a paradigm, and, understanding at least a vague sense of what data streams are. I mean, I know what data are, I know what a stream is, I can make some assumptions, but there was a lot of stuff that I was really missing here. And so the way I approached it, and again, I will take any and all feedback. So, as I go through this, if there's anything that's off or something that needs to be, more detailed, dive into, certainly let me know. But like with a lot of things, I like to think of it in the context of something that I work on, right? And where we can all probably relate to is this idea of building a client application that communicates with a server in some way. We can think of it maybe with web request, right? Where you're actually communicating with an API, which I'll show a little bit later. But this idea of, requesting information, there's some work done on this server, specifically a thread on this server, and then you get a response back. Nothing game-changing about that. But what we may not, well, we probably realize, but we may not necessarily know what's happening here, is that any number of things could be happening from some third-party system. And in this case, relevant to us is a database, right? Where we've got some kind of process happening in the database. So when you kick off that initial request, the server thread itself, part of the work that it needs to do is actually communicate the database. But at this time, while the database is off doing its thing, the server thread itself is blocked from doing anything else, right? Because it's essentially waiting for the database to do whatever the heck it's doing. And so the common response has really been to, a lot of times, and this is still really a common response, is to simply spin up more threads, right? Be able to create more server threads so that, while it's still cranking away on that database request, we may have a second request come into the server that we handle on a completely separate thread. And of course, you could imagine that if we expand this out horizontally, you could have all kinds of threading going on here. And that's a lot of context to manage, right? It becomes a lot more complex in code. It certainly becomes a lot more resource heavy. It just isn't the most efficient way. And as we were talking about, Lexi, before, it's that once you realize that this isn't exactly ideal for, we'll say, some situations. I mean, there's certainly no silver bullet in computer science. I think we all know that. But when you start to think reactively, in the sense that you may receive the request, right, on the server thread, and the server thread can then kick off the request to, say, a database or some third-party system without expecting a response, right? This idea that it can shoot off something and then not necessarily have an idea of when to receive something back, other than it's going to receive that back at some point, then that opens up the server thread then to continue work on the same thread in respect to something like request 2 or another request after that. And so this really starts to dive into this idea of more of a declarative type of setup where you're not concerned with managing the workflow steps or exactly knowing step by step what needs to happen, other than you just need a response or a result of some sort, in this instance from the database. And so as we start to think of this declarative approach, the next thing that we really think about is, okay, well, how do data streams come into this, right? Well, at first, whenever you first think of a data stream, right, I mean, it makes sense. You're like, okay, well, there's point A and there's point B, and there's simply a stream of data between the two, right? But if you start to peel back the layers of that, you start to understand that, okay, well, what's available in an actual data stream, right? What's the breakdown here of what I'm sending, what I'm actually using, and any updates. And you can think of a data stream really as, or really the anatomy of a data stream as, of course, it needs to be able to start an event of some sort. You need to send information, which is the variables that you see here. And then there's basically two things can happen. It can either complete as you'd expect, or it can have some kind of problem. And all of this, of course, is happening over some duration of time. But that's really kind of a problem, right? Is that you don't really know what that duration of time may be. You don't especially know how much information, at least from the raw standpoint of what's going to get sent over. And so there needs to be, or there's other ways, I guess, to do this as well, but reactive streams back in 2013 was a specification that was built to kind of wrangle this together and create a standard approach for being able to manage this. And again, it is a specification. So as we'll look, we'll see different implementations of this, some of which we'll actually use within the application. And others will be using the specifications to help create other specifications in the case of R2DBC. But with any specification in Java, or any, I guess, respectable specification, it does come with a technology compatibility kit, which is a series of basically check marks or tests that it has to pass in order to be a fully fledged implementation. But the most important part that we want to get into, and you actually mentioned it before briefly, was that this idea of non-blocking back pressure, right? So when we consider a stream, and we're not talking about the back pressure that you may, this is my small attempt at a joke, right? The back pressure that I get when I read or try to understand originally what reactive programming is. What I mean is, if you consider something like a fire hose, right? Or you're drinking water out of a hose, if, like the instance of a data stream, you can think of the stream itself being the water, right? And that you're receiving all of this water, or the emitted water and elements underneath, is that you may end up not being able to handle the full brunt of this. And so back pressure in this instance allows you, as the person receiving the water, the ability to say, squeeze that hose to say, no, I can't really take that much. Or, I need to stop it completely, and we can resume a little bit later. And from a very simplistic standpoint, makes sense, right? Is that I want to request from my point B to point A, hey, I'm ready for more items or more elements. Go ahead and send those to me, right? Seems very straightforward. And in this case, we can actually start to pivot into what we think of as a publisher and a subscriber, right? Where somebody's or something is publishing information or data in this data stream that we can actually view as an observable. And then this subscriber, which actually takes this information. But the problem here is that if just left up to this very simplistic design, you are really just offloading the problem from the subscriber to the publisher, right? Because the publisher may end up not being able to send as much over to the subscriber as requested. And so you run into this issue where you're really just creating a backlog really on the other side. And so though you can certainly solve that, there could be any number of ways to do that. That's where reactive streams come in as an API or a specification, really, to be able to create reactive solutions with non-blocking back pressure. So we won't necessarily dive so much into the intricacies of what's involved with the API, other than the fact that you can think of it as a collection of interfaces, right, that can be implemented and used in an actual implementation, which is something that we'll see as we start to dive into R2DBC. Now, again, why is any of this important, right? And you're probably thinking, I thought this guy worked at a database company. He hasn't talked about a database at all up until this point. Well, we really need to get an understanding of reactive programming and how it exists right now, within the development world, to get an understanding of why R2DBC exists. And first and foremost, of course, I think we can all at least acknowledge that it really is the next frontier of, specifically in Java and the JVM at this point for high efficiency applications, but it also exists in, in other mediums as well. And fundamentally, it's because we are creating a non-blocking approach of being able to efficiently, or most efficiently, be able to use our resources and optimize, that resource use. But a lot of times it's paired with this idea of asynchronous. That's probably because within the definition, we talk about asynchronous data streams, but people tend to think of this as asynchronous as in threading, right? And though it certainly can be used in an asynchronous fashion, it's not necessarily coupled to async, right? It's agnostic to the fact that it's synchronous or asynchronous. The idea that we really want to take here is this control of back pressure, or this use of back pressure to be able to create the most efficient non-blocking environment for our applications. And this is really important for databases, specifically relational databases, because if we think about NoSQL implementations, they've actually had reactive integrations and reactive implementations for a while. And it's taken a little bit for relational databases to catch up. And part of the reason for that is that there has been an API or a standard that has existed for a long time in JDBC, right? The Java Database Connectivity API. But unfortunately, as reactive as our applications are, our JDBC API is actually blocking really by design, right? I don't know if it was necessarily meant to be blocking, but the approach that it's taken within the API is blocking, right? Within our database operations. And so we actually don't have a truly reactive application unless we've got that non-blocking behavior at the database level, because at some point something is being blocked. And in this case, we're just pushing that down to the database. Enter R2DBC. Well, R2DBC if you hadn't caught on to the name now, is 2 R's for reactive relational database connectivity. And as Alexi mentioned, it was something that has been spearheaded by Pivotal and has really started to take off. And we'll see a little bit why that is in the next couple of slides. But first, it's good to define a goal before we start jumping into the actual specification and then an actual implementation of that specification. And so we need to understand, okay, so we have JDBC, right? And it exists. Why can't we just use, or why can't we just modify the existing JDBC API? Well, there's several goals that we'll get into, but obviously, like JDBC, it needs to fit in the JVM platform, but it also needs to fit into the reactive model seamlessly and really innately. It needs to fix a couple of things that JDBC has opinions about, right? So for anybody who's worked with the JDBC API, it can be a little too opinionated about certain things, which starts to put a little bit more pressure on vendors that may end up having to implement or create implementations off of the API. And so it ends up being a little bit of a pain in the ass if you ask anybody that's really working with JDBC. And ultimately, they need to keep the focus on SQL and relational databases and try to keep this new specification as simple as possible. And this is all in the hopes, right, that rather than having to kind of modify or, I guess, change JDBC API, we can use a new specification, R2DBC, to actually then provide the ability for an implementation or a vendor to come in and create a driver that's fully reactive and non-blocking at the database level. So why a service interface? Well, instead of actually having just a ton of implemented code, which may come with a ton of opinions, right? Because certain things could be decided, right? If we're talking about reactive development, there are several reactive frameworks and different libraries out there that certainly R2DBC could have used to everything from an actual publisher implementation to be able to put inside the specification. But instead, the creators of R2DBC wanted to keep it simple so that the driver authors and the API users actually could make the decisions and implementation, right? So they'd have a lot of flexibility. And this boils down to a couple of reasons. I only added a few of them in here, but some things that are really annoying are like the special character, like question mark binding within JDBC and URL parsing. The fact that URLs are pretty standard and have to be re-implemented or re-parsed with every driver and have an implementation of that. These are some of the things that become a little bit annoying. And so with R2DBC, what's nice is that though it seems like a small addition, is that it will handle things like URL parsing for you, right? Where you understand things like the scheme, a particular driver in this case would be MariaDB. You then add information to actually connect to the database, and then information for querying or setting up particular configuration differences between the databases themselves. But all in an effort to unify how URL parsing is done. But that's really only the beginning of it, right? The whole specification itself comes with a variety of different interfaces, which we'll see. Now, I'm not going to dive into all of them, but I am going to take a look at a couple of them. And anytime you've worked with the database, some of these things, or probably most of these things, are going to be pretty familiar to you. And that's this idea of a connection factory, which will create and kind of maintain these connections. From there, you, of course, want to work with a statement to be able to create a query off of that connection, which will then return results. And each of those results will have a collection or a tabular value of rows, which we'll dive into. So we're just going to take a look at these 5 really quickly. But one of the things that I want to point out as we look at a connection factory first and foremost is, well, one, the implementation, or not the implementation, the actual interface here is extremely simple, right? But one of the things that we'll notice off the bat with R2DBC is that, of course, as I've been mentioning, it uses reactive streams. So that whole span or kind of tangent that I went off really wasn't, I guess, a tangent, but it's with the idea of setting up, okay, here's the importance of using the reactive streams specification, and we're using that as the foundation for R2DBC. And so as you would think of a connection, when you go to create a connection, typically you create it, and you get back that connection object right whenever you ask for it. But of course, now we're actually going to be subscribing to a publisher to be able to return at some point our connection object, which we'll dive into a little bit later here. As we kind of continue down this chain, we can see that connection comes with a lot of the same functionality that you would expect and is available in JDBC, but of course still uses reactive streams and uses reactive development in order to be able to provide publishers rather than actual values that are coming back. And we'll see how we can actually use those within an implementation. So everything from being able to control your transactions to be able to create a statement. And a statement you can create off of the connection that happens immediately. But one of the most important methods probably in the entire specification is execute, right? Where we're actually returning a publisher of some object that it basically inherits from result or extends result. In this case, the interface. And so from there, then it really just boils down to options that you're used to having within database connectors, right? This ability to bind your parameters. So being able to set special characters within your SQL query, like a question mark or a colon and a named value, and then being able to dynamically set values into that. All of this comes baked into the specification for a statement within R2DBC. And from there, you're able to return a result. Now, a result is simply two things. It's going to have it's going to either return one of two things. It's either going to return a tabular set of results where you're going to get row information, row metadata information, or in the case of an insert or an update, you're actually going to return a count, right? Where it tells you how much or how many records were affected by whatever query, modifying query that you've been doing or that you've executed. And a row then simply allows you then to look at column information or cell information based on a column name, right? So if you have a column identifier, whether it's an integer or whether it's the name of the column itself, then you can pull it out. All of this, very straightforward, something that we're very familiar with. But again, this is just a specification. There's nothing here that's an actual implementation, and we won't see that until we jump into an actual driver or a vendor implementation of that. And in this case, of course, I work for MariaDB, and the logo's been splattered all over the place. So you could guess that I'm probably going to use MariaDB as the example. But we'll see that this process then of being able to use the R2DB specification comes from creating a MariaDB specific implementation or implementing these interfaces to create an implementation to use as a driver. And so, of course, in order to create a connection, you need a configuration. And that's going to take all of the values that you expect from a database, from the address of the database, the port number, username, password, and you're going to be able to build a configuration. From there, you can use that configuration to instantiate a implemented MariaDB connection factory. So we saw the connection factory interface, and the MariaDB connection factory simply implements that interface to be able to allow us to create a connection factory. From there, we can use a connection factory to create a connection. Now, as we saw before, it is a publisher that gets returned. So you can use .block basically to say, hey, no, I really need a connection because I can't do anything without the connection being established. So I need that before I do anything else. From there, then you are really kind of opening up the floodgates. Now, I promise all of this verbosity is not the way that we're going to be doing it. This is simply to show how you would use the implementation from a kind of more manual or raw perspective. So bear with me for a couple more slides, and then we'll jump into an actual implementation that will not be using this very verbose approach. But we really start by using the then established connection object to be able to create a statement. And we can expect that, we can enter in our query as a string, just, as expected. From there, we can execute it by creating a flux object, which is something with Project Reactor, which I'll jump into here in a little bit. And once we get the results, we can actually take and accumulate using map and flat map. Again, I'll dive a little bit more into this later, but we can basically accumulate these elements that are emitted into a singular publisher, which is our flux of type task at that point, which is going to allow us to essentially, as we see here, use the row data and the metadata from that row, then to be able to map that into our task object and return that through a publisher or a publish event. Now, we can also, as I mentioned before, some of the things that were available from the specification are things like bind. And we can see that very simply, we can actually use bind as named or, simply just parameterization, where we can actually say, hey, at this particular instance, or maybe you wanted to name it, I want to assign this value to my query and be able to execute that. From there, we can expect to receive maybe a single value, which is what mono, it is 0 to 1, essentially elements that you can expect back, as opposed to flux, which is 0 to many or 0 to n elements that can be emitted. And we can expect from this case that we want something like a number, an integer that basically tells us how many records were affected. But as I said before, all of this was extremely verbose, right? We got a pretty good idea in the first part of R2DB section of what the actual specification is. And then the second part, I kind of went off the rails showing how you could implement it. But that's great to be able to see it. And if you wanted to create a data access layer all on your own and be able to manage all of the data access objects and work with all of the built-in functionality to do that, and then be able to abstract away as much as you wanted to, that would be great. But a lot of times we don't have the time to really worry about that. And luckily, there's a lot of libraries out there that help us integrate not only with reactive development or reactive programming libraries, but we can also use it to be able to integrate into R2DBC. And so I'm just gonna go ahead and jump directly into a demonstration. I am going to be using Spring Initializer. And I just want to be able to create a Maven project, right? Because in this project, I'm wanting to take my launch out here. I'm going to create a Maven project, as I mentioned. I'm going to be using Java, though, of course, you can generate a couple of other languages you see here. I'm just going to use the latest stable. I'm going to keep everything basically default. As far as packaging and the version number that I want to use, I'm just going to change a couple of the names here. I'm going to change it to the group to MariaDB, com.mariadb. I just want to change the name of the application to do. And I'm going to flip over to the dependency side because there's a couple of things that I want to add. First thing I want to add is I want to be able to create a reactive environment for my Spring Boot application using what is known as WebFlux and Netty, which we'll dive into a little bit, but I'll keep the focus mostly on R2DBC. From there, I actually want to take a look at R2DBC. Well, if I type in R2DBC, I can see a variety of different options. And what you may notice here is that MariaDB actually isn't on this list. And the reason for that is, as I mentioned before, it's still in beta. So as soon as it actually becomes a fully qualified GA, that we can, announce, then of course we'll make it available out here as far as the dependencies are concerned. So for now, we're just going to be using Spring Data R2DBC library so that we can use Spring Data to basically help eliminate a ton of the verbosity that I was running into whenever I was doing that first implementation. And lastly, because I'm lazy, I'm going to use Lombok, which is going to help me add or reduce some of the scaffolding or some boilerplate code through some annotations. And really just one annotation, because I don't want to write one getter and one setter, which is pretty lazy, but I guess that's what's happening now. So I can go ahead once I've done that and I can generate. It's just going to put that into my downloads folder. And I want to, let's actually see, I think I had already, let's just move this, let me do this, I don't know the name it. Okay, so I want to drop that into R2DBC as this folder, and that's just where I'm gonna house this. Now, I do have a completed version of this, so if for some reason my live development kind of goes off the rails, I will switch over to the completed version so that we can actually see an implementation of this. But I think it's best to kind of start with nothing and then be able to add those pieces in real time so you can really see how easy and fast it is to get started with R2DBC within the application. And by, way of, just happenstance, then once you've implemented, then you get all of the benefits of a reactive relational development environment. So let's go ahead and let's close down some of this, and I'm going to use Visual Studio Code to create or open up my new folder of this. So the project that I've created and I've placed in my folder, I'm just going to go ahead and open R2DBC. And if you haven't used Visual Studio Code at this point, it is just a free open source text editor, code runner. It is essentially, it's been a lifesaver for me because you can use it for a ton of different languages. They've got a ton of different extensions. Of course, you can use a variety of other text editors or code editors, but this one is pretty simple and it's free. And it's got the dark theme, so I like all of those things. From here, I actually want to start by taking a look at my Explorer window on the left-hand side. And of course, it looks just like a Maven project as you'd expect, but I want to jump into the POM configuration file where, of course, I get a lot of the project information as far as the version, the fact that I am using certain dependencies like Spring Boot, I am using R2DBC, Spring Data, all these different things. But as I mentioned before, we weren't able to add the dependency for MariaDB because it doesn't exist inside of Spring Initializer as an available dependency. So I'm just going to paste in manually for now this dependency. And you can find this out on the GitHub, which I can kick over the links for any of that stuff for the project because the R2DBC implementation from MariaDB is completely open source. You can find all this information there as well. So I'm just going to save that. And that's really all I need to do in order to work with R2DBC with MariaDB, and what we'll see is working with it within Spring Data as well. And to keep things even simpler, I'm really just going to work out of one file, which is to-do application. Now, if you're writing a real application, of course, you would not be doing this because it doesn't make a lot of sense. And I'm sure the application would be much larger than this and it would get extremely frustrating. But for our sake, we are just going to be working out of one application. And in order to save time, I'm going to paste in, I'm going to paste in all of the imports that I need so that I don't have to add those individually. And I'm just going to go ahead and minimize that. And that'll allow me just to flow through and actually write the code without having to worry about whether or not I missed an implementation of some sort or an import somewhere. But where I want to start, so we've got an application that does nothing, right? It's just a regular Spring Boot application that at this point offers nothing really for us to do other than the fact that it will build and then it just does nothing. So where do we want to start? Well, I typically like to start by setting up the configuration, right? So I want to actually use the actual implementation of our MariaDB R2DBC connector. So in order to do that, I need to set up configuration. I want to do something to enable R2DBC repositories as something that I'm going to be using within Spring Data and R2DBC, specifically Spring Data R2DBC. From there, I just want to create a private class that allows me to create a configuration by extending an abstract class that exists within the Spring Data R2DBC library. So I just want to call this R2DBC DBC config. And I just want to then extend abstract R2DBC configuration. And then I just want to create a bean for a public factory creation. So this allows us then to be able to, let's see, is this configuration? I can't see if it's, that's the one. So now I just want to be able to, essentially I'm creating a method that's now going to allow me to create my specific implementation of a connection factory. And this is really the source of everything, right? Because in order to connect to MariaDB, I need to have an implementation using a MariaDB connector specifically. And so that's what I'm going to be doing here. So I can say connection factory, and I want to then return this part is going to be, okay, I want to use the MariaDB connection factory, and I want to build in a configuration. So the configuration, I will use builder. Let's see if I can. From here, then I want to use the builder object or the builder function then to be able to chain together some of the information. So I want to connect, I'm just going to connect to localhost. I then want to establish the port, even though it is the default port, and I think that I don't think it would have a problem if I just left it blank. It's good to mention that the default port for MariaDB, if you're not aware, is 3306. I have a user called app user, and the password, oops, let's see, so password, 1, 2, 3, and I want to use a database to do, so specifically the database I'm going to be looking at as we build our application, which I will mention what we will be building here. Let's see. Oh, sorry, that is actually called username. All right, so from here, let's see. Oh, yeah, it would help if I actually created a new object. Okay, so from here, now we have everything we need to actually establish a connection to MariaDB. And the part that I didn't mention was that this application is simply just a to-do application, which is going to allow us to create tasks. And those tasks simply have an ID, a description, and whether or not they've been completed. So a very simple to-do application, or the beginnings of a to-do application. But before we can actually do anything with our database tables, which is just simply a single table called tasks, we need to create an object that I can use to persist the information or use the persisted information from storage and use that within persistent objects or models that I can, be able to map to on my Java application side. So from there, I then now get to use or justify Lombok by using @data, which is going to allow me to avoid having to create getters and setters. I want to create an annotation for requiring args for a new constructor. So everything that's indicated that's necessary within this model, I want to require, and that's because I'm going to create a method later on or a process later on that's going to spin up some values as soon as the application starts. I then just want to indicate the table to then create my task object. Inside here, as I mentioned, I just have some very small pieces of information, which are the ID, and I have a non-null. And the reason why I'm setting this annotation is so that I don't have to, or that it's required, and it's the only thing really that I have to supply when creating a new object of type task. So then I can here, and I want to add the very last one, as I mentioned, which is this field completed, which tells me whether or not the task has been completed. So at this point, I have the connection and I have a model object, much less verbose than what we were looking at and having to create manually using the MariaDB connector for R2DBC. But now I want to get into the meat of actually using this, both the model and then the configured connection. And in order to do that, I'm actually going to use a repository. So I'm going to call my repository task repository, which essentially is just going to allow me a method for doing simple CRUD operations at the beginning, and then being able to extend that with queries a little bit later on. We'll see. So I can use an existing class, existing class out there called reactive CRUD repository. And this is then going to allow me to specify the type of repository or the types of information that I want to be able to both input and output, basically just use within this repository, and then establish, okay, well, what's the primary key data type on this as well, which is integer. That is all I need for this repository, because as the name suggests, it comes with all of the basic CRUD operations, and specifically what we'll be using are the insert, the update, and we will be using, actually, well, I guess we'll be using all of them. So I'll actually be using everything from creating, reading, updating, and deleting. So we'll get to see exactly how all of that is done. Now, in order to actually be able to use this, let's see if I can minimize this, use this in any kind of viable fashion, I need to expose this to some kind of outside processing. Now, I could just write some terminal-based or console type application, but I want to go ahead and expose this as an API, which is why I brought in the reactive web project as well as one of the dependencies. So I want to establish first a Rust controller using the Spring framework that allows me then to establish the API or the endpoint using request mapping. I then want to just establish that if I want to hit it, I want to call it API/tasks. And then from there, I actually want to create a controller class called task controllers. And this is just going to expose a couple of endpoints that are going to allow us to manipulate the data all the way through the MariaDB implementation of R2DBC. So I want to auto wire a usage of the task repository so that I can actually use the repository directly within this controller. Now, this could come with any variety of layers, right? If you're writing an application, you could be using a service in between your controller and your repositories. I'm just using it directly because as this is just a demonstration, it's a very simple process of getting this started. But from there, I want to be able to create a get method, which is going to allow me, just like it sounds, to be able to get information eventually from my database. But I want this to be able to be fully reactive, right? And so I want to then return a Flux publisher object of type task. I'm just going to call this get. So extremely simple. If from here, I'm just going to use my repository dot find all. Now, this is part of the CRUD repository. So this is a method that's already existing as an implementation within the Spring Data R2DBC library, right? So I use the reactive CRUD repository as I extended actually the reactive CRUD repository to create my task repository. And if I want to receive back my values, that's all I have to do. So that's my select star on task. It's done in fully reactive. Now, that is something that is completely available for us to do. But of course, we don't have anything inside of this table, this task table. We don't have any data inside of here. So I'm going to create something very simply, and I'm actually just going to paste this in here because it's not as important that this exists, because this is just something we're using for demonstration purposes. But I'm going to create a component, right? So this component class is something that's actually going to, after construction or after essentially dependency injection does its thing with the task repository, basically what this means is that this load method is going to fire when it's going to execute when I fire up this application. So as I'm in developer mode, I can just run the project. It's going to kick off this method. Now, what's important about this method is that I'm going to go and use a couple of different methods. This allows me to cheat a little bit without having to create endpoints. I can basically show off how we can use different methods that are available within the reactive CRUD repository. And then we'll, of course, use the MariaDB implementation of R2DBC to do things like delete. So I'm going to delete, and when that has completed, right, then I'm going to add in new task. And if we saw before, this is why I added the arguments for constructors, and I added a non-null specifically onto the description, because I'm just going to supply a couple of string parameters here, or a couple of arguments that inside of this flux just, and simply it's going to allow me then to create and map those to, if we can get a cool little graphic in here, it's going to allow me to take my string objects, and it's going to allow me then to be able to create and map into new task objects. From there, I then want to take those elements, those emitted elements of tasks, and I want to save those into my database. And of course, nothing can happen with any publisher unless you've actually subscribed to it. So I then have to say, okay, I want to subscribe to kick off this process. And the summation of this process then is that I'm going to clear out anything that's there, and then I'm going to add 3 tasks right off the bat. And this is going to allow us to be able to test our get method to be able to take a look at all these tasks. So hoping that I have done everything correctly, I am going to start the debug process. And I can simply do that, as you saw, by going up to run on VS Code and just say start debugging. But certainly I could use I could build the package, and I could actually run the project using command line. This is simply just a lazy way of doing that same thing. Now, from there, I want to test this out. I am going to use, just because it's a little prettier to bring in here, let's see if I can't. So I'm going to bring in an extension, and you could use Postman, or you could use curl in order to do the same thing. I could probably just actually, since it's a GET request, I could just go straight to the browser and enter this in. But one of the things that I like to use is something called the Advanced REST Client, which is an extension onto Chrome, just simply because it's so simple and easy to use. But I want the formatting from the JSON that comes back from my endpoint. So I've started the application, and if all went well, that means that my post construct method executed, and I then was able to get task. So if I execute my local host 8080, which is the default port, at this endpoint, API/task, or sorry, at this route for my API. And then at my endpoint, I specifically am just specifying that I want to use the get method that I established within inside of that controller. And we can see that I have 3 new tasks. And because I have used this database a lot just for testing, the auto incremented IDs are 67, 68, and 69. Now, one of the cool things that we can do, of course, is that we could continue to add different methods. But what's nice is that we can actually branch beyond just the CRUD, the simple CRUD operations, and we can actually add functionality into our task repository. There's a variety of different ways that you can do this, but just for kind of a quick show of what's possible, as you can get started, I want to add a new modifying method. And this is something that an annotation that you would actually tag to anything that does an insert, a delete, or an update. Anything that's essentially modifying data, you want to have this annotation on. And from there, I can simply just say, okay, well, I want to query, let's say, update task set, and I want to say the completed equals a completed value. So maybe I want to be able to toggle a completed value for a specific task ID. So that way I can start to create maybe more of an application that allows me to actually manipulate this task list that I'm creating. From there, I want to return an integer value. And this is going to tell me how many fields are affected, or sorry, how many records are affected by this query. And I can then return a mono publisher value, which is, again, it is going to emit 0 to 1 element or 1 values. And it's going to be of type integer in this case, because I'm returning a count, as I had mentioned, is one of the capabilities of a result. Now, from here, I can just say I want to pass in integer ID, of course, and I want to pass in the completed version. And this is then values that are automatically mapped into the query using named parameterization, right? So we can see we've got the colon completed where we're going to put completed, and we've got the colon ID. So now all we have to do is really add in a way to use this. We're going to call this just a put. And don't judge me too much for I'm going to get a little lazy on the implementation of this. And I'm simply just going to add these in as request URL request parameters. So probably not the most secure thing, or maybe not the best convention even for building an API, as I'm just going to add ID as an actual parameter, but it's pretty easy to take a look at what it's doing. And then I also want to add in my completed field, because I want to say, for a particular task, I want to toggle the value somehow. Now, from there, I then just want to use my repository, and I can see that now I have a newly available, of course, method called update status that I can pass in ID and the completed value, right? So here, now we have exposed a put method, which is going to allow me just to toggle the value. So I'm going to rerun, and I then am going to switch back to using my put, or my advanced REST client, to indicate how I want to use my put. Now here, let's see. Let's go ahead and clear this value. Okay, well, we'll just put this in here. We will put, and I guess I got to remember what okay, 70. I guess we ran it again. So every time I run it again, it deletes and re-adds. So now I just want to toggle, let's say, task 1, which is ID of 70. So here, I just want to say, okay, for localhost 8080 API task, for my put method, I want to toggle that to true. It then returns a value instantly of 1, which means that 1 record was affected. And then I can confirm that by flipping back over to my Git, and I can see that I have able to successfully update the value that exists inside of my MariaDB database by using this API. And that is really the extent of that demonstration portion, only because there's, you know, so much more that you could certainly do and dive into it. I do want to point out, I will put this, that's part of the problem with, we'll just say a new window. One of the things that I do have available, let's see an application. I should probably have this bookmarked somewhere. But I have created a fully fledged version of this application with all of the CRUD, you know, kind of fleshed out. And I am using a React.js front end. And I have several backend options, but one of them is R2DBC. And I've gone through this exact same process, but instead of putting everything into a single file, I've used a little bit what I would say better conventions. Now it's all still in the same project, but from here you can actually see full repository implementation, just like I had before. I actually use a controller just the same way here, but I actually expose a couple of different endpoints, which then allow you to actually create an application where you can do everything from saving, you know, inserting, updating, deleting, and selecting the values. And it uses, yeah, obviously all the same tools that we're using now, with instructions to be able to do this as well. So it's a little bit bigger of a version of an implementation, but the actual setup for this takes about 5 or 10 minutes. So if you just wanted to pull it down and test it out, you could do that pretty easily. It all comes with instructions inside of the README of how you would do that, as well as how you could set up just a containerized version of MariaDB, which is what I'm using now. I'm just using a Docker container version of MariaDB on my local machine. It's free and very easy to set up, and it contains all the instructions for being able to do that. So, and of course, if you have any questions on this, you could email me or tweet me or anything like that. So with that, I think that I will flip back over to the slides only, and okay, yeah, because I only have one more to really go through, which is this roadmap. So as I've said a couple of times, the R2DBC connector is in beta right now. So there's still work, of course, being done on it. We are looking heavily at performance and adding more capabilities, specifically around things like data types like JSON, GeoJSON for geospatial data, specific types for that, and then pluggable types for things like JSON, INET4, and Boolean. Basically, as the server, MariaDB server progresses, then we're going to add support for that inside of R2DBC at the same time. But that is the gist of it. So I didn't do a very good job of checking the questions. Sometimes whenever I get into the code, I tend to just kind of to zone. So if I missed any questions, I really apologize about that. Okay, cool. So let's see. Yeah. Sorry. Anybody, yeah, feel free to, you don't have to ask the questions on, you can ask them in chat specifically if you want to, but you can also, you know, feel free to use voice. Either way it works.
Yeah, thank you, Rob. Yeah, Vaughn, please ask a question.
Yeah, so it looks like, okay, so Vaughn asked me a question. It says, does R2DBC require the use of Reactor? That is not a requirement of R2DBC, but that is something that may be required from the implementation. That is a, so again, the reason why the R2DBC specification is so small, really, comparatively, and really it kind of lets you do whatever you want to, is that they didn't want to make implementation decisions specifically for things like, you know, choosing a library like Reactor or something like that, or, you know, options available within, you know, certain publisher subscriber implementation. So No for R2DBC, but if your question is, do you have to use Reactor for R2DBC with MariaDB? The answer is yes. So hopefully that helps a little bit.
Yeah. Well, I guess the thing is, right, we've got our own reactive streams implementation in our platform. Yep. And, you know, I mean, I guess it's okay, but introducing Reactor to support MariaDB is kind of a, well, I don't know. It's a little bit of a strange decision for us to have to make. You know what I mean?
Yeah. So, you know, and this is, I mean, all of this feedback is really good for us too, because certainly we don't want to, you know, limit anybody from being able to use it. Now, the other thing is that because it's still in development, I mean, there's still decisions that can be made as far as abstraction and things that we can do to make it a little bit more inclusive or, you know, flexible in that sense too. So yeah, I would, if we want to connect after this, you know, maybe we can see what it would take if you could use it to see exactly, we can even connect directly with Diego, who's the developer on there on R2DBC, and see, you know, if you have any input or, you know, direction, advice or suggestions, because this is certainly something that's new for us as well.
Well, you know, the thing is, I could see if the driver is implemented using Reactor, but if the client could be a subscriber of any reactive,
yeah, we'll have to look at that. I mean, we can,
you know, streams type, that would be pretty cool, right? So then
yeah, well, I can just bring up the GitHub. You can, continue to talk through it, but I figured I could just bring it up directly
I mean,
as well.
Yeah, my whole understanding about the whole reactive streams thing is it shouldn't matter what any given publisher or subscriber is using. It's just the interface that has to be honored, and as long as you honor that interface, it should be, you know, possible to support anything. So to be nice to, you know, as far as I'm concerned, you guys should be free to use any kind of implementation that you need, whether it's Reactor or something else or your own thing, but be nice to just use our reactive streams. Yep.
Yeah. Yeah. And yeah, I can completely, I mean, I can certainly see your point on that. Personally, I am a big fan of being able to do those types of things too, right? Whenever I write code, I like to have the control. And there's a lot of times I don't like to bring in dependencies for a lot of those things, but it does look like here that they do have a dependency on Reactor core.
Yeah.
But again, that doesn't limit what we may be able to do in the future. So
Sure. I mean, this is beta. It's good. You know, I'd be happy to meet your developer and talk to you more about it. The other thing is just wondering, you're running a Mac with MariaDB in a Docker container. How does that perform? Is that actually pretty good, or?
Yeah, so I use it from a development perspective. It works, I mean, pretty well. I mean, I don't run anything crazy on it, so you know, it's hard to tell. But one thing I will say is that the new community server 10.5 now includes not only the traditional row-based data storage that you would get, you know, even with MySQL and MariaDB in the past, but it also contains a columnar database storage engine like natively. And I will say that I put about 40 gigs worth of information, so roughly about 200 million records, and it performs lightning fast.
Pretty cool. But you're running a Mac. The thing is, my experience with both Postgres and MySQL is that it's really slow on a Mac, you know, because of the Docker.
Yeah, and you know, to be honest, you know, I'm pretty partial to Mac. Coming from one of the things I think I mentioned before was that I spent a lot of time in mobile development. So my OS of choice has really just been Mac OS by default, because it's the only way you can really build all the platforms for mobile devices all at once. So my relative experience with fast or slow to you, it may end up being pretty slow based on the way I use it. But for me, because I'm not really comparing it too much to anything else, it seems to be pretty snappy. Now, comparing that to maybe, you know, Ubuntu, like putting that in, you know, natively or kind of installing that directly. I haven't done any kind of personal checks or benchmarking to see how much faster, but from a development aspect, if you're just wanting to try it out, it spins up nicely and it's pretty snappy from the amount of information that I put in there. Now on the transactional side, I can't say that I put just a ton of information. It's really mainly been on that columnar side, which of course is built specifically for large amounts of information. So
yeah, cool. Yeah, I mean, just a little off topic, but a general question on your experience with that. So thank you for.
Yeah, thank you. Yeah, I'm always happy to talk about stuff that I actually know about. Now, if you get too deep into reactive, I mean, that's what I was telling Alexi, is that I'm still pretty new with a lot of that stuff. So, you know, I'm learning every day, but it's pretty awesome. You know, some of the capabilities, seems like every day learning something new. And having to adjust, you know, content that I've created that is just completely wrong. So it's been pretty exciting.
Don't worry, Vernon. ARM will fix all of that stuff when the Macs switch over, right?
That's what they say.
Well, it's actually more about I guess it's more about the file system, right? Because if you're writing internally in Docker, I guess you're writing to a Linux file system, and then it has to like thunk over to the Mac file system, and that's really the slow part. So in the tests, like in the test suites that we have for our JDBC database implementations, just like inserting a few thousand records just takes minutes, you know, or, you know, it's just crazy.
Yeah.
Horrible.
Yeah. Hey, along those lines, you know, your demo was, you know, you're using a reactive driver, but you're also doing 3 records, which is probably, you know, a single, you know, allow that many records in one hit on your reactive streams anyway. Do you have anything where you're really using back pressure and really pushing it back into Maria and seeing how that works?
I don't yet. And so since this is kind of in the earliest, but I mean, that's like the most valid question, right? Is that, okay, this example doesn't really, besides, you know, being able to see how it's implemented and seeing something set up or scaffolded in a way, it doesn't really show the value of R2DBC, but that is something that I'm going to begin working on pretty soon, just because, you know, within future content and the book coming up, I think that's exactly right. You have to have something that actually shows off the value of using R2DBC. So unfortunately, at this point, I don't have anything, but I just have to, I've got egg on my face because I completely agree with you. I think that I should have something like that.
Thanks.
Yeah. And sorry that I don't as of yet, but I will try to whip up something, because I think that that's really the best way to show this off, right? Is first start with implementing it, but providing a use case of some sort where you can really start to see why you would want to use it. And really, I'd like to have a use case where I use both JDBC and R2DBC in tandem or side by side to really show that value off would be the ultimate goal. And be able to write, you know, some kind of blog post on performance or something.
Yeah, I'd love to see something that kind of shows the transition from legacy to reactive, you know, like a microservice that's interacting using, you know, standard, you know, SQL and threads. And then, okay, here's what it looks like, you know, halfway, and here's what it looks like all the way over to a proper reactive microservice that's doing it right.
Yeah, I like that. I like that approach too, where you show like a transition as a form of steps rather than like all or nothing. It's like, here's how it's, because ultimately that's how you're going. I mean, any larger shop or any legacy project, it's not going to be, you know, an all or nothing type of process, right? Nobody's going to put any money towards something like that. They're going to want to see it iteratively. So yeah, that's a really good idea.
Yeah, we have to.
Yeah, cool.
Any other questions? I want to thank Rob again for this great presentation. And I actually think, you know, we really got into the setup, all right? We got into the basics. So I think, Rob, you know, when you have the kind of demo of real back pressure use, that would be part 2. So let's kind of consider it as a part 2. And, you know, we're definitely welcoming you back anytime you'd like to continue the series, because I think it's a really great introduction. So we are looking forward to next meetup, and definitely happy that the book you're working on the book. So definitely you're looking forward to that.
Yeah. Thank you very much, everyone, for having me. And yeah, I'd love to do a part 2, because as Brian said, I think that it's extremely important to be able to, part of what I've been focusing on really with kind of my own ignorance up until this point has been just wrapping my head around all of this stuff, right? And, being able to get started. And as I kind of move through these chapters, it's crazy because I had never really even considered writing a book. I just thought, well, this would be a really good way to learn something as well. And it really does force you to learn all of the nitty gritty about something. So it actually works out well from a timing perspective, because I think as I go through that process, it's inevitable that, the examples that Brian brought up, I'm going to have to use something like that in order to be able to justify R2DBC, right? Because otherwise, the argument would be, well, I mean, I could just thread out some JDBC, right? I could just create some small modifications. Why do I have to bring in and completely change the paradigm of what I've been developing up until this point? So, yeah, I think it's great. It called me on it too. I mean, I think that I would love to, even, come back as soon as possible, to be able to give a part 2, just because that puts the fire under me even more to get an actual implementation. Plus, I'm sure MariaDB would love something like that too, because a lot of the information out on R2DBC has actually been fairly at that same level, right? A lot of the information you see is kind of this starter. We really need that next level of, okay, well, how do you take the next step? Or man, I think a blog post or some kind of content where you talk about how do I move from legacy, right? Java, which has existed for decades, applications, which may be years and years old and using a particular style. How do I move that into more of a reactive paradigm? And what does that look like? Because, that process isn't happening overnight, right?
Yeah, Robert, an important thing to consider is it's not just people writing applications. It's like, platforms or frameworks such as, reactive ones. For example, we're based on the actor model. So we have our own interfaces over relational databases, over, NoSQL, whatever. And as soon as we make like a JDBC request, our actor is blocked, even though we're fully asynchronous. As soon as we interact with anything that blocks, we're blocked, and there's nothing we can do about that. I mean, because ultimately something's going to eat a physical thread on the processor, right? So and so from my standpoint, R2DBC is wonderful from the perspective, the basic concept of it.
Cool. Yeah, I completely agree. And I think that, I mean, that part of the things that I got into a little bit was this idea of, being fully reactive, right? Creating a fully reactive solution, because as you mentioned, once you're blocked once, depending on how often that may crop up or, where that exists is kind of this choke point, can be pretty detrimental. And having this, now, I mean, I guess if you were using a NoSQL implementation, there have been reactive solutions for NoSQL for a while. And so this is really encouraging from a relational database side, just because, it creates this. And I think that if I'm not mistaken, there are a couple of different, or at least at one time, there were other specifications out there as well. With R2DBC, there were other ones, like lesser known ones. And I don't know if that's still the case now, but I think, and you guys may know better than I, but I feel like R2DBC is pretty much won out with those at this point. So it's really exciting. This is cool. I'm excited to join more with this group and learn more about it, because I'm still kind of in the infancy of a lot of this stuff, but it seems like I need some back pressure of my own, because I'm drinking from the fire hose and some of this stuff.
All right. Thank
It
you,
looks like,
everybody.
Peter, you might be muted. I think you were saying something, but
Yes.
sorry. I still can't. I don't know if anybody else can. I'm getting zoomed.
No. We can't hear you, Peter.
He's unmuted from Zoom, but maybe on his side something is muted or.
Sometimes my.
Can you guys hear me now?
Yep. Yeah. There you are.
Okay, great. Hi, everybody. Just want to quickly comment. I've launched a small service, one of our small microservices in production using R2DBC.
Yeah, cool.
It's primarily written in Kotlin.
Yeah.
But we use Project Reactor's Kafka client and Spring Data with R2DBC, since Kotlin's ORM framework exposed doesn't support R2DBC yet. We just use Spring Data repositories.
Yeah.
It works pretty well together. And kind of, I think Vaughn, you had a comment earlier about interoperability. So I also use Kotlin Flow, which is another reactive streams implementation, compliant implementation. I use that together with the Reactor, Kafka, and R2DBC in the same stream. Even I convert them all eventually to Flow, and that part works pretty well. So the interoperability seems to work pretty well. And in this case, I don't use MariaDB, but I use Postgres. And the Postgres driver also uses Reactor Netty client to, at the binary level, implement the binary protocol in a reactive way. So they seem to work well together, at least for me.
Cool. Yeah, very cool. Yeah, it's encouraging to hear the usages of it too. And if anybody would love to kind of contact me after this, I would love to get everybody's contacts, just because it seems like from a reactive point of view, you guys have a ton of experience and come from different backgrounds of using it too, that I'd love to pick your brain as I kind of move through the process of learning more about it. This has been really encouraging.
Yeah. All right. Thank you very much, guys. So really happy to start learning about R2DBC. Looking forward to the next installment, and I see you guys at the next meetup.
Hey everyone, thank you.
Sounds good. Thank you very much.
Thank you, Rob. Thank you very much, guys.
Everyone.